continue from where we stopped from the audio, and we'll be looking at, still on chemistry for SS1 students, we're still looking at carbon and its allotropes. Now, from our last class, we talked about allotropy, the existence of two or more elements or compounds with different structural formula and also different structural properties, different physical forms and properties, but the same chemical properties. They can be different. We give an example of diamond. Some of the allotropes of carbon, we have the crystalline parts, we have the diamond and graphite. There are two different things when you see them naturally. Even their structure differs, but they have exactly the same chemical properties because they are all carbon allotropes. Now, for the non-crystalline ones or the amorphous allotropes of carbon, we actually saw charcoal, we saw coal, we saw coke, we saw carbon black. All these things are all carbon allotropes. They have the same chemical properties because they are all gotten from carbon, but different structures and different physical properties. Now let's look at some chemical properties of carbon allotropes. When we talk about chemical properties, we are also referring to as the reactions, the possible reactions of carbon allotropes. So whether charcoal, coke, diamond, graphite, all of them are carbon allotropes. They can all be represented with C, carbon, because this is the element, carbon, C. So wherever you see C, don't just say which part of the allotrope are we talking about. Is it the coke? Is it the charcoal? Is it the carbon black? Or be diamond or graphite? We are still talking about the same thing, carbon. Now, the first one is combustion. Combustion. When we talk about combustion, we're talking about burning. Burning. Heating in the presence of air or oxygen. Of course, when you're cooking, or maybe your mom is cooking with firewood, of course, the presence of air, there's always air. Oxygen from air supports combustion. So because of that, it actually gives out lots of heat. That is why it's an endothermic reaction. And the heat alone helps the food to burn, whereas all other compounds or even molecules are actually gotten from this combustion reaction. Now we actually have a general formula for combustion reactions, but you will see that later when you get into SS2. But in case you want to know that, CXHY plus X plus Y over 4O2, that's presence of oxygen and so on, giving us carbon, 4 oxide and water. Now in combustion of carbon allotropes, we have a product, carbon oxide. It can come as carbon 4 oxide or it can come as carbon 2 oxide. This is carbon, can come with anyone. Can be coke, diamond, graphite, all of them. In the presence of oxygen, this is burning, gives rise to carbon 4 oxide. Now, oxygen is in excess in this process because we have just one molecule of carbon atom, whereas oxygen is actually present in 2 atoms. That was why we got the carbon 4 oxide, because oxygen was in essence. And we talk about that the second reaction. We have limited supply of oxygen. Remember we said that oxygen is actually present in air. That was limited air. Now we have a limited supply of oxygen here, and that is why we have carbon monoxide or carbon 2 oxide formed. Now remember I said it's an endothermic reaction, releases heat, lots of heat to the atmosphere. The second one is combination reactions. Combination reactions. Now, combination actually has to do with joining two things the same, bringing two things together to form one. Now, carbon combines directly with certain elements. Those elements can be metals or non-metals. Now, for metals, carbon can combine with calcium, it can combine with aluminium, but for non-metals, it can combine with sulfur, can combine with chlorine, it can combine with hydrogen. Now, hydrogen can serve as a metal and at the same time as a non-metal, depending on the reaction it takes place in. Now, this is carbon, this is calcium. Now, let's see this reaction. Carbon, 2 molecules of carbon. This is a metal, calcium. Now, combination reaction will give rise to one product. This. So, we have the calcium carbide. We have the calcium carbide. Most of us must have heard about carbides. Now, this is just a simple reaction that takes place between carbon, the calcium, a metal, and carbon to give us the calcium carbide. Now, for aluminium, 3 atoms of carbon with 4 atoms of aluminium will give us the aluminium carbide. The aluminium carbide. You can write the name. Aluminium carbide. Now, this reaction is with non-metals. We are using sulfur as an instance. Here, we don't form carbides again. Remember, when it reacts with metal, it forms metallic carbides. But when it comes to non-metals, it forms other products. Now, this is carbon, a non-metal. Sulfur, we know that is a non-metal, usually from our periodic table. This will give us the carbon 4 sulfide. The carbon 4 sulfide. Remember, combination to give 1. Now, this is the second one. We are using hydrogen here. Hydrogen here, although a metal, but serves as a non-metal here because of the reaction it's taking place in. So, carbon plus hydrogen will give us methane. Now, in other reactions, we can have another product. But in combination reaction, 2 or more reactants combine together to give us just 1 product. That is why they are combination reactions. Now, the third one is reaction as a reducing agent. Now, carbon is a very serious reducing agent in the sense that when it's involved in a reaction, it reduces the oxides or reduces that particular compound to a lesser one, giving a lesser oxidation number, whereas itself is oxidized in the process. Now, carbon reduces the oxides of less reactive metals to form their own metals themselves, but this itself is oxidized in the process, and that oxidation gives rise to either CO2 or it gives rise to CO, carbon 4 oxide or carbon monoxide, depending on the condition. Most times, high temperature is actually needed in reactions as oxidizing agent when it comes to, as reducing agent, when it comes to that of allotropes of carbon. Now, let's make use of this. We are using lead 2 oxide. Now, how do I know this compound is lead 2 oxide? We find out the oxidation state of this compound. Lead, oxygen is -2, giving rise is equal to 0. Now, we have lead is equal to this -2 going over to the equality sign. We have +2. So automatically, the name of this compound is lead 2 oxide. Now it has an oxidation state of 2. In combination or reaction with carbon, it reduced the oxide of lead from lead 2 to ordinary lead. This is just the lead metal. And any compound in its natural state has an oxidation state of 0 to give rise to the carbon monoxide. So from this particular reaction, lead 2 oxide that had an oxidation state of 2 has been reduced to 0 because of the reaction it had with carbon. Hence, carbon is a strong reducing agent. But at the process, it took over the oxygen from the lead 2 oxide, to form the carbon 2 oxide. Now we have this particular also reaction. This is copper 2 oxide. The same process. If you make use of the process, we are looking for the oxidation state of copper. This is -2. We will still get exactly the same +2. So definitely that is why it's answering copper 2 oxide. The oxidation state of copper is +2 here. On reaction with carbon again, it became reduced to ordinary copper metal, having an oxidation state of 0. And here we have the CO2 formed in the process. But remember, there is actually a very high temperature. The conditions varies. The condition for the production of this, let's just say because it's still +2 oxidation state turning to 0 and +2 oxidation state turning to 0, definitely they will be the same thing. Definitely they're not the same thing because of the formation of 2 different compounds, carbon monoxide or carbon 2 oxide and carbon 4 oxide. So depending on the condition of the reaction, that is actually what forms the products. We saw the chemical properties of allotropes, carbon allotropes. We saw combustion reaction or burning. We've seen combination of bringing up 2 different molecules or compounds to form one. We've actually seen reaction as a reducing agent, reducing a less reactive metal or an oxide of metal to form a lesser one. That's giving a lesser oxidation state or bringing the metal into just an ordinary metal state, metallic state. Now, but at the process, carbon is actually being oxidized. That is why it's a reducing agent. Now, you write an assignment for me. Write on coal. Write on coal. Now, coal is an allotrope of carbon. So we are going to be treating that particular allotrope of carbon because of its wide range of activities. Now, we are going to write about coal in not less than 1 page of a foolscap sheet. I don't want anybody to write just 2 lines or 3 lines for me. In not less than 1 page of a foolscap sheet, write on coal. Submit to my WhatsApp number 090-799-61788. And if you have any question, still ask me on that group. Thank you very much and see you next class.